Hi, thanks for watching Fire Engineering Training Minutes. I'm Nick Martin, and today we're going to talk about knee walls and some methods that we're going to use to deal with that style of fire. If you look at the structure I have here in front of me, it's a very common dwelling. It's a 1.5 story Cape Cod style dwelling. This type of structure here is going to pose a knee wall problem. We're going to go inside in a little while and we'll show you what knee walls look like from the inside, but outside let's look at some features that identify this as a structure that would probably have knee walls. It's a 1.5 story building, meaning by that I have a full first floor and I have a second floor that has a very steep pitched roof on either side. These windows up here are called dormer style windows. Those are hallmark indicators of knee walls inside of that living space. We'll see what that living space looks like from the inside there in a moment. When we have a knee wall, what we have is an enclosed void space towards the edges and the sides of the house there that can contain fire conditions that can go undetected or be difficult to access from the inside. So our scenario here might be a fire that has started on the first floor and then extended up through the void spaces in the walls or the floors to get up in these knee wall spaces above. The characteristics we're going to find inside is that we typically had a lower story fire or a fire in the walls. We've got that knocked down and now we're getting a smoke and heat condition with no visible fire in the floors above. This house here has a couple unique characteristics. We note the pitch right up here by these dormer style windows, but if we walk over here to this other side, we'll see that there's another involved pitch. So over here on the delta side of the same house, you can see we have a kind of interesting configuration. You can see that we have, on the same roof, we have two different pitches. This window over here on the delta side indicates to me that there is a finished living space of some type in this upper floor over here on the delta side. But if I look at the pitch over here, I can tell that there's a knee wall space in this room here. It's a very separate space than the knee wall space over there. So from a ventilation perspective, what we're about to do here next, if I had fire conditions in both spaces, I may have to ventilate or deal with both knee wall sections separately because they're probably not connected on the inside. So let's take a look at how we can ventilate this situation from the outside. Okay, so now we're going to look at how to ventilate this knee wall structure. We know we got a fire in the knee wall space. So what the guys are going to do is they're going to be laddering this building in a specific manner. We addressed this in a previous training minute, and what they're going to be looking to do is ventilate between the two dormers. When we're taught to ventilate a roof, we always focus on ventilating at the highest point, up at the ridge. And for most scenarios, that's the correct way of doing things. But here we want to very specifically ventilate the knee wall space. If the guys inside open up that knee wall space prior to it being ventilated from the outside, that can cause a very intense and drastic change in conditions for them on the inside. So if I ventilate it here first, that's going to relieve a lot of the conditions. We can then go inside, open it up, and we'll see that in a minute. So what we see here is that while one firefighter has gone ahead and gotten the ladder up and in between the dormer spaces, our second firefighter has gone to mask up. So he's about ready now to head on up the ladder while the second firefighter, who originally threw the ladder, drops back to get his mask on. So our first firefighter is going to go up. He's got his hook and his Halligan. Secures his hook on his ladder where he can get it. Second firefighter gets the saw. He's ready to follow him up. The first firefighter is going to go up there and he's going to take that Halligan. He's going to choose the proper space. He's going to sound the roof. And then he's going to use the pike of that Halligan to get us a little bit of a foothold that the saw firefighter can step out on and safely and comfortably make his cut. So if we look at the back edge of that dormer there, right about where the middle of that hook is, on the inside, what we'll see here in a little bit, that's where the actual wall in the living space is going to come down. So when we make the cut, we want to make our cut kind of just below that line. So Tim's going to step out there on his Halligan and get a comfortable position, and he's going to begin to make his cut. All right, you've noticed that he made his far and his top cut first. He's now going to make sure that he's outside of his saw area as he comes down and opens up the rest of that hole. Now that we've got our cuts made, our saw firefighter can step down out of the way. Our hook firefighter can come down a couple rungs and begin to open up that hole. So as you can see, we got a little hung up there in our cut. That can happen. This is the real world here. So let's take a look at why. If you look right here, here's the back edge of those dormers I was talking about, are kind of indicative of where the wall is. Well, this dormer actually goes back a little bit past where that wall is. This right here, and you can see the drywall, that's the interior wall. We'll see that inside from a minute. So the problem that we had here is that our top cut was above the interior wall. What that caused to happen is when we went to louver over our rafters, you can see this section right here, it won't louver because it's hitting on the interior wall there. So the way we would have had to solve this is either make our initial cut a little lower right here, or if we encountered that problem after we've already made our cuts, then a quick way we could solve that is just make another quick top cut, maybe a foot or so below, to get us below where that interior wall was, and then we'd be able to quickly louver this roof board here. So this is what it looks like from the outside. We got our knee wall space nicely open. Let's go inside and see what this looks like on the inside. Okay, so here we are. Now we're inside the exact same area we just cut, ventilated from the outside. So we talked about how to identify knee wall construction from the outside. Looking at the inside, here's what you see. On our top floor, we have these sloped walls that are typically going to be on the front and rear of the house, okay? They come down here a good distance and they shoot straight down. Inside here, that's our knee wall space, okay? That's where we're talking about there being hidden fire on us that's not readily apparent but is producing a lot of smoke and heat up here. What we'll see in a few minutes when we open this wall up is sometimes this knee wall space here is directly connected to the attic space above, sometimes it's not. So we're going to see how that plays out here in a few minutes. So our scenario was here, we have our hose team They're right out here at the top of the stairs. They haven't been able to make their push yet because they're getting beaten down. But now that we ventilated that knee wall from the outside, we're getting some good relief. So the inside truck team is going to come in ahead of the hose line, and we're going to get them to open this wall up. So guys are going to come on in. We got a hook and a Halligan. It's a good combination to open up this low wall and these higher ceilings. And we're going to begin to open up this knee wall space here, all right? So Mike Champo talks a lot about the punch technique to quickly open up these style of walls. You can see these guys are using good success, using that punch technique to open up the space. You can already see right down here where he's opened up the side wall. It's free to the daylight. That's where we ventilated between those two dormers on the outside. This was our first dormer that we ventilated between, and the other dormer was over in the next room here. So as we open up, we're opening up this knee wall space. Our hose team could come in behind us, and now they can begin to knock down the fire. The benefit of doing this the way we did it is, if we did not ventilate from the outside first, when these guys opened up the knee walls in here, those conditions would push down on them in this enclosed space. That can be fatally hazardous, and it's definitely very difficult to work under. But by providing that initial relief from the outside first, we're kind of splitting where the conditions go. So now we can more comfortably and in a more controlled situation open it up from the inside to chase it and put it out with extinguishment. So as we finish up opening up our walls and ceilings, let's see how much these two things connect here. Let's open up this wall and stuff, connect this wall here to the ceiling. Open a couple bays up there, the whole thing. All right, so what we can see here is that these spaces do connect a little bit. And what I mean by that is, if you look right here, here's our knee wall space that we were working with, and you can see the size of that and how much fire and conditions we could get in there, especially with these Class A style materials, okay? Now, one thing to note about these spaces is, too, a lot of people turn these into storage and/or playrooms. On large houses, these spaces can be huge. They can be, you know, I've seen kids' beds in them. We'll go look at that in this house in another spot. So it's something we got to be concerned with. So that's our knee wall space. It's ventilated from the outside. But if you look here, we have a short run going up to the attic, okay? But they're connected, okay? There's enough room in there. Now it's maybe only, you know, what is that, 6 inches or so? That's enough for some conditions to run up and light off the attic. But here's what I'm saying is we ventilated the knee wall space well here, that if the attic is also on fire significantly, then we may have not done enough ventilation to the attic space. So depending on the degree to which the knee wall is connected to the attic, how big or small, or if that connection is present at all, that may indicate that we need to ventilate both the knee wall space and the attic separately. So that's a little bit of some of the construction feature of how this goes, and you can kind of see why we've done what we've done. Let's go in the other room here and see what this storage option looks like. Okay, so where I am in the house now, if you remember when we were outside, we were on the Delta side, and we looked at the different pitches between the two roofs. We're over on the other side here, and if you were to look past me here, you got to trust me, it's pitch black. What we just did on the other side, there's no connection to the space that I'm in here now. So we're trying to demonstrate here that on this style of roof, there was actually 2 separate knee wall spaces, and right now we've only ventilated 1. I'm inside the knee wall space, so you can get an idea of what kind of size this is. I'm in full turnout gear, and I can move around in here fairly comfortably. A toddler, a young child, whatever, they can turn this into a play space. And these spaces can be a lot larger than what I'm in right now. You can also have a lot of storage in here, which can just add to the fire load. So knee walls, when present, we got to deal with them a special way. We got to make sure we identify them early because they can be a very, very hazardous condition. Thanks for watching Fire Engineering Training Minutes. I'm Nick Martin.